Game, begin.
So my name is Piotr Przybyl, and the Germans call me Piotr ohne Vokale, which means Piotr vowel-less, because there's no vowel in my last name, as you can see. I mean, there are two in Polish. Anyway, what I do, most of my professional life, I've been doing JVM programming, mostly Java, but also some Scala and stuff. And I'm mostly like server or web developer. So I don't do JavaScript, for instance. So that's about me. So when people ask me, where do you work? The answer is, when I leave my bedroom, my sleeping room, it's the second door to the left. Because I am self-employed as remote freelance software gardener. And at the moment I'm working for one small company in Paris. And today's talk is about context. The name is CONTEXTVS. I don't know how many of you guys remember the presidential campaign in the United States in 1992. I believe it was like a slogan made by Bill Clinton's, "The economy is stupid." So he wanted, or his folks wanted to make it really important that the economy matters. The economy is very important. So they said the economy is stupid, and I say CONTEXTVS. Context stupid, because I believe the context is very important in what we do every day. Okay, a little agenda for today. So we'll start with some real-world examples, not IT stuff. Not strictly. Then we'll talk about some IT world dilemmas, and then I'll show you two simple techniques how to discover context. But before we start, who have heard about the caveat emptor rule? Okay, was one guy. Well, okay. So in a Roman law, there was this caveat emptor rule, which means let the buyer beware, and it's still working like in the United States. Let's say you want to buy a house in San Francisco, and there's a seller, and you're the buyer. So unlike many European law systems, it's not the seller's responsibility to assure you that everything is okay with the house. It's your responsibility as the buyer, as the taking party, that everything is okay with the house. Therefore, caveat auditoris, let the audience beware. Guys, I want to play a game. I want to play a game with you, and with all of you guys. We'll play a little game, just a little warm-up. So let's say we have such a crossroads. Which car can go first? Names, red, blue, both. Blue, you say blue. Who says blue? Who says red? I must warn you that in this very situation, it's most probably the blue who's going to go first, because this one has this little triangle sign which says give way, which means the priority is with the blue car. The blue car can go through the crossroads as the first one, and the red one has to follow. Let's change the context slightly. And now, which car can go first? Red one. Who says red? Who says blue? Still some doubt. I chose you correctly, that was good. Okay, so in this very situation, you see, we didn't change the crossroads, I mean the direction of the tarmac and so. We didn't change the position of the cars, we just removed the sign, we just slightly changed the context. Which means now, the red one can go first, because we have, I mean in France, in Poland, and in most of the Europe, we recognize the Vienna Convention of road traffic. Which means if your right hand is free, you are free to go as the first one. So this one has a free, free right hand, this one, and this has to wait because his right hand is blocked. And let's change the context slightly. I spoiled that, sorry. Now, in this situation, which car can go first? Who says red? Who says blue? Who says I don't know? Okay, I think you were first. Okay, some jellies for you from Poland. I throw, you catch. My friends, in this very situation, the answer is it depends. It depends where this crossroads is located. In the United Kingdom, like in England, most probably the answer is whoever goes first, or they need to agree. If there are no signs, it means there is no priority. There is no reverse, like left-hand side rule. Maybe in countries like Singapore, they still observe this right-hand rule. And in other countries, it might be totally different. So you see, 1/4 of world's population is driving left side, right? That's important. That's 25%. And if you are going to program this self-driving car, this might be important, right? So your cars don't crash because they know whether they're in England, in Singapore, somewhere in Africa, or in other locations. The context matters. As you can see, context exists, and we have to go and find it. We can't guess it. We can't apply, okay, so if we are riding on the right side, and there's this right-hand rule, then in England, because they're riding on the left side, they must have this left side rule. It doesn't work this way. You know, you can't guess the context. You can't compute the context. You can't assume the context. You have to go and find the bloody context. 169. Is it far? Is it far? Usually the answer is it depends. Of course it is. Let me tell you, this is 169 kilometers. Is it far? Yes. 169 kilometers in space. Is it far? No, you say no, it was far, no, it's not far. Okay. This is a picture showing the trajectory of Mars Climate Observer. There was such a mission at the end of previous century, and the goal was just to start, a little probe from Earth, so it would like orbit Mars and collect and send us some data about Mars climate. And it was created by in the United States of America by NASA and Lockheed, like a consortium, and this was the planned trajectory. Like they assumed that the probe is going to go this way, so here they need to start this, little maneuver boosters, so it will go into this orbit and will orbit Mars and send us beautiful pictures of Mars, about the pressure, temperature, winds, and so on and so on. Because there is apparently some atmosphere on Mars. It's not like on the Moon. But it went this way, and as you can see, the Earth was here, so they've lost the radio contact, and they never gained it again. And after 2 weeks of hectic investigation, what happened, they found out that most probably the actual trajectory was 169 kilometers less, which means the atmospheric stress, the stress from the Martian air was too high, and it simply disintegrated, broke into pieces, right? So that's why it was the radio signal sent to Earth here, but no signal here. And now, this is the only picture, as far as I know, taken by this probe. This dot here is Mars, and the whole mission costed about $330 million American dollars. So I think this is the most expensive picture taken by humankind. And now, so we may wonder, why did it happen? You see, and the issue is that NASA had a contract with Lockheed, and they were saying that we are going to send every data in a system international, like metric units, meters, newtons, kilograms, the stuff. But the engineers in Lockheed, because they are so much into aviation, they kept like feet, pounds, and so on, the imperial units. Which means if one sensor sent to another computer 12, this sensor meant 12 pounds, but this received it at 12 newtons. And that resulted in this serious gap of almost 170 kilometers. The safe height was about 80 kilometers, so they missed just a few, for the orbiter to be successful. Skipping the context can be expensive, as you can see. They skip the context of the units, and sometimes it can be very expensive. Okay, another question. How fast the light travels? I have still some jellies left. Sorry? That's the good answer, Catch. Yeah, he doesn't shout it out 3,100 kilometers per second. He asked, in space? And this is important because in vacuum, this is the speed of the light. More or less, we are missing a few meters, right? But in the air, it's like 90 meters slower in Earth's atmosphere. Still, it's not a big deal, you know, for radio waves or for lasers or something. It's like you can get rid of it and you can live with it. It's not that important. But if let's say you are measuring the speed of the light in diamonds, which have much higher refraction, then it's less than 2 times. So it's then smaller, more than 2 times smaller. You know, and so that matters, for instance, for fiber optics. You know, how the fiber optics is made, and they cannot just shout 300,000 kilometers, because they need to ask about, you know, the medium for this light. So that was very good. This is where I'm going to take you with this presentation, I hope, to ask these questions. Is it in space or where is it? Because in elementary school we are taught 300,000 kilometers, boom, a mantra, right? And that's it. Okay, so make sure your mantra matches the context. So when you shout out like 3,100 kilometers, you know for sure that we are talking about the space, or at least the air. What can you see here? We're in Toulouse, so we should know. Okay, this picture was taken in Cape Canaveral, as far as I know, and here we can see the starting platform with the Columbia shuttle, I believe, and here we can see that the shuttle is connected to a huge bomb called fuel tank with 2 smaller bombs on side. And the trick is to just not to blow these bombs, but just to use them wisely and at various stages. So some people may ask why these 2 bombs are smaller than this huge bomb in the middle. What's the reason? You know, there's a myth about it. Most people say it's a myth, but still it works well for this presentation. So in a railway, there's a thing called structure gauge. And it's very good pictured by this tunnel. So it's the maximum size of the train that can fit into this structure gauge, you know? So this is a structure gauge. Like, you can think of it like this is the structure gauge. So what has the structure gauge to do with the space program? It's just these are solid state, like solid fuel boosters. These can be tanked here. This is like, it's not a fluid, right? These 2 boosters. So they are assembled in a rocket city in Utah, I believe, and they are transported using railway. So that's why this is limited, you know, the size of this booster, because of this structure gauge. So, but why do we have such a structure gauge? Because the guys who started to build a railway in the United States or in the North America came from London. Okay, I know this picture is from Lisbon, but still, you know, it was about 2 trams passing each other. That's why we have the distance between tracks is like 4 feet, 8.5 inches. This here, and it's about because the 2 trams had to pass each other in London City. But why couldn't they make it like, you know, wider, for instance? It's because the plan, or the streets in the London City were set by ancient Romans. The city was planned by ancient Romans, and their definition of wide enough road was that the 2 double-horse chariots needed to pass each other. And because of the size of horse's bottom, there's the size of this tram, there's the structure gauge, and there's the size of this bomb. So as you can see, sometimes you can't alter your context because you will not rebuild half of your railway track, right? Of your rail system, and context can live long, even for millennia. Very long. Okay, what you can see here is an open space, obviously. I hope you don't have to work in places like that. Anyway, this is not the kind of open space I like to tell you about, because this one was taken in Moscow, as far as I know. Anyway, imagine another kind of open space, like 30 years ago, a big hall. Like like a big hangar where they assemble these Airbus planes, for instance. It's just instead of the planes, you have desks, rows of desks, like 1 row, another, and third, and so on. And there are people who transform paper forms into digital data. So they called in English data entry clerks. You know, people who worked as OCR before we had OCR, more or less. And they were working like in Pakistan or Afghanistan or another stan or somewhere even in more far east. That's the context, okay? And you see, usually for data entry clerks, you don't hire people who are very efficient in typing, like you guys are. So we can, you can do your JavaScript, you can do JavaScript, you can sip your coffee and still do JavaScript. They don't work like that. They have three places where they have to look. They have this paper form, they have the keyboard, and they have the monitor. So it was like, read from the form, type on the keyboard, and check on the monitor if that's correct. It was going like this triangle, right? Paper, keyboard, monitor. Paper, keyboard, monitor. So wise engineers from Western world, let me put it that way, thought that they may try to use a feature like this. The PC speaker. You know, a little speaker inside your computer which makes beep, beep. Or beep, beep, beep if there's no graphic card, or whatever. You know what I'm talking about. So they have decided that maybe they can apply this PC speaker in this checking process. So when these folks enter the data in an incorrect manner, they just make a mistake, then this beeper will beep, beep. So they don't have to check the monitor because they already know they made a mistake, right? So there's this, they don't need to check the monitor because no sound means everything's correct. So just like paper, keyboard, paper, keyboard. You know, it should be faster. So it went into production, and there was a massive drop in performance of these data entry clerks, like 30 or 40%, some say. And why did it happen? Because something was missed, the context. The culture of these folks. My wife is working for a Far Asian company, and if you're higher in the hierarchy, you have respect. Even if you say something stupid, the folks below you, are respectful to you. If you're older than somebody else, you have respect. It's just that respect is granted, basically. But it works also the opposite way. If you do something stupid, and they know, the folks below you know you did something stupid, they won't tell you that in your eyes like we do, hey, you made that stupid. They would just know, in themselves, that you made something stupid, that you made a mistake, that you did wrong. They will just not say it loud. So, now let's imagine you're this data entry clerk, and you made a mistake, and this bloody speaker beeps. So everyone around you in this freaking large hall knows you made a mistake, right? So what do you do in order to avoid mistakes? You double check the monitor, there's no mistake, before you press enter. That's how it works, So this piece of speaker, it wasn't an improvement in performance, it was a downgrade in performance because of the cultural context. I believe here in Toulouse, in France, nobody would give a damn. It beeped, so what? This is also how it would work in Poland. It beeped. Oh, doesn't really matter. But it's not working like that there. Another cultural example I have is that there was an attack made by Russians. Everyone believed it was made by Russians, and the Russians wanted to say it wasn't them. So they created a denial, a dementi, if you will. So it wasn't them, it was just one clever guy from Italy or Spain or somewhere like that. And they wrote a blog entry post that it wasn't us, the Russians, it was one clever guy from Italy, and I'm the guy. Ha ha ha, stupid Americans, I just hacked you. But they missed one thing in this dementi when they wrote it. And that made the CIA or FBI folks think even harder that it was the bloody Russians. So what did they do? When you see something like this, does it look strange? Maybe for you it does because you're French, okay? But in Poland, it looks perfectly normal. This is how Poles would write it. This is how Americans or folks from the United Kingdom would write it, and Germans too. But it was written this way. So, and it wasn't just one emoticon in here. It was every place in every place this smiley was replaced with this one. So you may wonder, so why is it proving that it was Russians or someone, using not Latin keyboard? It's because there was this keynote about games, this like Mortal Kombat or something. So you have to press combo on Russian keyboard to get a colon or a dash, right? Like in Mortal Kombat to get a combo, more or less. So that's why they use triple brackets. Just to make sure, because if you use 1, it might be like a mistake, a typo. But if you use 3, then it serves as this smiley. That's why Privyet in Russian translates into this hello. On the other hand, when I get something like this, I know it was sent from France because of salut, because of this space here. You guys use this space before exclamation mark. And so I can quite easily detect, French person trying to type to me in English because of this space here. So this is the cultural context, right? It matters. It's in us. I mean, us developers, but it's also in our users. So we need to make sure that this context match when we create software which is delivered worldwide. Last example, I believe, from a friend of mine, David. I'm working with him, and he created a simple page. One of these small companies which do everything. They sell everything. There's like a boss, a secretary, 2 drivers, and that's it. That's the whole company, right? And they needed a website. So there was a website written using Django or Drupal or whatever, just a web framework, and he created typical login form, and he sent to Miss Secretary these login credentials, not using Mail, but using just email. So he mailed her the login and password and expected, that the user acceptance test go okay, and she says it's okay, so we pay you the money. The answer was, I can't log in. And there was like a whole week of this ping pong game. Why can't you log in? Because I can't. When I try to do this, it doesn't work, but it should work. I've tested, it works for me. You know the story, right? But it doesn't work for me. So, in act of despair, he established a screen sharing session with the lady. And when you get a login and a password by email, what do? You copy-paste, exactly. And she didn't, despite being quite efficient with computers. So David asked the lady, wait, why didn't you just copy and paste this password? Because I can't select the dot, was the answer. Which dot? The dot which is in the password, the last character. But there's no dot in the password. No, there is a dot. I can clearly see it. So he didn't send the dot, but she saw the dot. Any ideas? No. Sorry? No. Sorry? No. That was the answer. You said that? Okay, sorry, something on the screen. Yeah, but it wasn't just. Sorry, I didn't hear that. It wasn't just something. It was a dot left by a fly. Interesting thing about the lady's brain is that when she saw it, in every other image being displayed in this monitor, she knew that this was just a dot left by a fly. But in this very context where Outlook displayed this password, it looked like exactly matching the password. So sometimes context is freaked up beyond any recognition. Sometimes it's so. Okay, so we're going into a technical part. A little introduction here as well, because guys, I've been recruiting people. And so when I recruit people, I like to ask them questions to see their how professional they are, to see their efficiency and so on. And sometimes these are questions like this. On the other hand, I'm also a bootcamp teacher, which means that there are these eager wannabe junior developer people who paid a lot of money and they want to be programmers. And they expect that then they have a question to a guy who's doing Java for 15 years, and when they shout the question, he shouts the answer. And they are very frustrated when the answer is, it depends. Because they ask a simple question, right? So there should be a simple answer. It depends is not a simple answer. And this is one of these questions. So let's say this is a recruitment process and I'm going to recruit you, okay? So I'm asking a question. Which sorting algorithm is the best or the fastest? No, you're professionals. Okay, let's say you're dummy. Okay, let's say you're dummy for a moment. Which algorithm would you choose? Quicksort, exactly. 80% of the time it's quicksort. I throw, you catch. Oh, sorry. Sorry. And this is also because we are taught so at universities, and it's also because of films like this. Sorry, let me put it like this, okay? So this is a comparison of algorithms. See, quicksort 1, merge sort 1, insertion sort is here, and so on. Let's choose another like data. Maybe here. Again, you see quicksort 1. Something else, or like in here. Quicksort 1. Yeah, and we could just, follow this this movie. And I think there are two problems with this movie. First, it's the music, obviously. Another one, I have a question for you. Who in this room has such a case in their real production system that you guys are sorting numbers from 0 to 100? Exactly. It's purely artificial. It's academics. It doesn't exist in the real world, because in the real world, like in Scala, for a set you have like empty set, 1 element set, 2, 3, or maybe even 5. Above 6 elements you have they switch for hash set. But for small elements, like for not so many elements, they have different implementations of set, because small sets of data are that common. So I think this example should look more like this. Let me, oh sorry, I've forgotten, just presentations. DevFest Toulouse and Java, yep. It should look like this. Yeah, you have 4 elements, and you sort 4 elements, and you see insertion sort 1. And it's not surprise. It's not surprise at all. See? Back to slides. So, by the way, this demo is on GitHub, so you can check it and play it on your own. So when you have to sort numbers like this is 1, 4, 2, and 3. In bubble sort, you have 5 comparisons, and in quicksort, you have 6 comparisons for such sets of data, and for something like this. And you can check it at Visual Algo. And you see, so quicksort is good, but bubble sort is better. Do we have any Italian in the room? Because they would tell you that le mieux est l'ennemi du bien, right? So this is good. Sorry, this is good, but this is better for this very case. Factors about sorting. So there's an initial order. It matters. There's a keeping initial order. If it really matters, if 2 A's should be in the same order as at the beginning, it's the data set size, as I've shown you. There's a cost of comparison, because if you can't cache the Roman numbers, you have to turn it into like algebraic version with each and every comparison. So there's a cost of comparison. There's a cost of swapping 2 elements. Depends if it's an array or a list. There's a cost of inserting an element, which is totally different for an array or a list. Cost of index-based access, like give me element 5. Cost of additional memory if you have an accumulator, and so on and so on. There are many factors about just such a simple thing like sorting algorithm. There is no the best algorithm if the data is unknown, because the data is your context. Right? So if somebody asks you what's the best sorting algorithm, you need to ask what has to be sorted, where, and so on and so on. That's the answer. It depends. So there was a case in Poland. We had a thing like nasza klasa. It means our classroom, literally. And it was like kind of a Facebook for Poland. Now it's mostly gone because of real Facebook. And they were so overwhelmed by their success that when everyone wanted to log in during like peak hours on Sundays, after dinner, they didn't even manage to log you in. And the story was, so it was like our classroom, yeah. And the story was that they hired a database administrator who just added some indexes. And these indexes made their database so fast that people were finally able to log in. Is it really true? In indexes are perceived as a superhero of databases. If you have a slow database, you just add some indexes and that's it, you know, indexes to the rescue. Wouldn't be so sure because indexes are used in where clause. So if you have some queries without where, indexes are not going to be used. Indexes are built and balanced during inserts and also, of course, updates and deletes, right? So this is where they're used, built. And they make sense for fairly distributed values. Like I saw a database. They had a database in Poland. They were shipping something, and they had a column for a country code, right? And like 98% of these codes was PL for Poland. So indexing this doesn't really make much sense, right? Because what do you index? 98% of PL and maybe 2% of other values? And things need to be easy to index. What's easy to index? Numbers are easy to index, like integers, or dates are easy to index, or like strings up to 3 or 4 characters are easy to index. If you have the whole lorem ipsum and so on, you know, half of the Bible, it's not easy to index. That's why we have Elasticsearch, right? Not SQL database. Indexes are not free lunch. In fact, nothing is. And ingredients of the index and the way you consume it matter. They really matter, like with the lunch. And the way you process your data is your context. So imagine you have a simple e-commerce application, and you're adding for a whole month, you're adding like an invoice, an invoice, an invoice, an invoice, right? And you're indexing this invoices table, right? And you do nothing but just index and index. Or where you select with precise ID, so there's no chance to use this index. And then at the end of the month, there's one report for CFO. How many goods have we sold? You know, the net, the taxes, and so on. So we just run one query to utilize this index, and every other insert query is slowed down by indexing. That's the context, right? So maybe the CFO could wait, you know, just like, maybe they can even wait 5 minutes once a month. But for our users, like, you know, all these 5 milliseconds may matter. And it may matter for you if you deploy it in the cloud, because you pay for every tick of the CPU, for instance. So it might matter in real money. OK, so there's another task from my recruitment process, print sorted list. Who can tell me how to print sorted list? Of children's names. In typical 3-tier web application. Huh? OK. So let's say these are the names, Adam, Anna, Hubert, and this is the application. It's a mobile application, right? And let's say it's about GPS tracking. So you have 3 children, and you know to know where they are. You're a parent, you know, a mommy, daddy, or just a parent. And I'm not very good at drawing, sorry. So this is database, these are application servers, and these are the clients. You know, like let's imagine computers, and this, my friend told me this might be a BlackBerry. Okay, so let's imagine this is a BlackBerry. This is it. So how do you print in this app? How do you print sorted list of children's names? What do you do? You get jellies, but you didn't get hired. And I'll explain to you why. This is it. This is it. This is the perfect answer. This is the perfect answer when there's a database in the stack and need to sort something, people just shout, "Odebai!" This is what the academia has done to us, our universities, like, you know, like Pavlov's dogs, you know, sorting, ding, 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 Odebai. We have to print the list, right? So we don't have to send a sorted list from the database to the servers. The list doesn't need to be sorted in this channel as well. It has to be sorted here because we need it to be sorted for printing, not for communication here and there. So you, most probably, would like to solve it here using the bloody JavaScript. Because trust me, in JavaScript, you can sort 3 elements, right? So there's no need to bother your database to create a temporary table on the disk, open a cursor, you know, to then lock it, then release it after the whole query, and so on and so on. Really, you can do that even using a brick, for a cell phone. All the buy is not for free, basically. Any other data processing is not for free as well. And if you are in the cloud, you are in the cloud. Your database is in the cloud. Your application server is in the cloud, but not the cell phones of your clients, right? You don't pay for that CPU. The purpose of data processing is your context. If we were to log sorted list on application server, we'd need to sort it in application server or in DB. But if we need to print it on an endpoint, like the very endpoint of the system, we don't have to sort it before. We just need to sort it before the printing. And some say, okay, but if you have 200 elements, it might be difficult to sort using JavaScript. I mean, the application will slow down. You will see that, okay? Did you hear about anyone having to trace 200 kids? Exactly, that's the context. Interrupt in Java is broken. I love this. People say because it doesn't stop instantly, blah, 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 yada, yada, yada. Interrupt is broken, I hate the wall of text, but this is the wall of text I need to read. So read it with me. And interrupt is an indication to a thread that it should stop what it is doing and do something else. It's up to the programmer to decide exactly how a thread responds to an interrupt. But it's very common for the thread to terminate. It's very common, but it's not obligatory, mind you. This is the usage emphasized in this lesson. And do you know what I like the most about this? The URL it's published on. It says essential. This is the essential knowledge about threads and interruption in Java. That the thread doesn't have to die after being interrupted. We kill threads using interruption. That's okay. I mean, this is the way to stop them. But it doesn't mean that interruption is only for killing or stopping the thread, basically. So in other words, interrupt means, and now you know why I got this video here. Okay, interrupt means, may I have your attention, please? A thread is sleeping, a thread is waiting, a thread is doing something else. And you, by calling an interrupt, are doing just, sorry, may I have your attention, please? This is the contract behind interrupt. It doesn't mean stop. It doesn't mean destroy yourself. In fact, this method was deprecated before it got implemented. Right? Because threads can be stopped in a generic way. It's a very nice article about it. Okay, I don't have time for this. Okay, simple way of finding and determining a context. So we can just ask why. And why, and why, and why, and why. Does it ring a bell? It's the 5 why principle. It's the simplest thing. So, let's say you're a manager in a factory and you're walking and you see in the hall that there's oil spilled on the floor. And you may just say, hey, Johnny, clean this up. And Johnny cleaned this up. Case solved, right? Not really, because you can go, hey, Johnny, why is this oil here on this floor? Oh, boss, because the pipe is leaking. Oh, why is the pipe leaking? I don't know, I will find out. And 2 hours later, Johnny comes and says, it's because the pressure, boss. The pressure is too high. Oh, and why is the pressure too high? I don't know, I need to check. And then it checks that it's because of the Tommy, because there's this loading ramp, and Tommy is putting too much load on it. That's why the pressure is too high, that's why the oil is leaking here. And you found the reason for the oil here, right? So you find out that the actual reason is Tommy not giving a damn about health and safety. That's the reason, not just the leak in here. A bit more advanced, I like this, I call it Fishikawa. It comes from Japan, as far as I know, and it's actually Ishikawa Fishbone Diagram, and it looks like this. It looks like a fishbone, so there's a defect, or just an effect, and you chop it into smaller things, like you can see environment, methods, machines, or materials, or personal, and then you find like sub-reasons, or sub-problems, or sub-defects to find the actual, reason. So when a client comes to you, hey, Francois, add this big red button in the page in here, you just don't add the big red button. you keep asking why and decomposing the problem into smaller pieces, right? Using this fishbone diagram, it works as well. So if you want more, there are more mantras I try to get rid of. So, you know, one thing I don't want you to do, so I don't want you to go tomorrow to your office and say, hey boss, you know what, there was this funny guy without vowel in the name yesterday in the conference, and he had a soul. So, you know, he said that we are sorting wrong. We need to revisit all the places where we are sorting something. And this is not what I'm trying to tell you. If you're sorting okay, it's most probably okay, right? It's just when somebody asks you as a professional, as an expert, what's the best sorting algorithm, you just don't jump out with quicksort. But you ask, you know what, give me more details, give me the context, because it depends. Just remember the context exists, and the obvious one might not be the best. This is a tweet from Kat Beck. And a decent answer to an interesting question begins with, it depends. And a decent answer. So if you want to give decent answers, you have to start them most probably with it depends, not just quicksort. And always, everyone, feedback. Not just this conference, not just me, feedback every speaker. There was one shy lady, she gave me that paper, she said, I'm too shy to tell you that. And it reads in Polish, I'll be thinking about your presentation at night. Good job. So I'm accepting papers, tweets, any kind of feedback, and every other speaker at every other conference is doing that as well. So feedback the speakers, please. Always, everywhere. Merci beaucoup. C'est tout.